Hey guys, welcome back. Today we are going to discuss about the analytical functions in Oracle. So analytical functions are used to compute an aggregated value based on a group of rows. The difference between aggregated functions and analytical functions is an aggregated function returns a single row for each group, whereas analytical function can return multiple values for each group, and these groups of rows are called windows. Please note, analytical functions are the last set of operations performed in a query except order by clause, meaning all the join operations, where clauses, group by, having will get completed before the analytical functions gets started. So we will be discussing three important analytical functions in this session, which are rank, dense rank, and row number. So the first analytical function is rank. It calculates the rank of a row in a group of rows and returns a number. Rows with equal values in the ranking criteria receives the same rank, as you can see here. And to calculate the next rank, Oracle adds the number equal to the tied rows to the current rank. As you can see here, salary 29,000 is twice in our table, and Oracle has assigned the rank 3 to both the salaries. And to calculate the next rank, it has added the number equal to the tied rows to the current rank. So we have two rows which are tied, and hence to calculate the next rank, it has added plus 2 into our current rank, and hence we are getting the next rank as 5. Let's look at the syntax of rank analytical function, and it is rank, then we need to use over keyword, which specifies that the rank function will get processed after all the joins where clauses completes in the select query. Inside this over keyword, we can assign our partition by column names and the column for which we need to calculate the rank in order by clause. So let's look at some examples of using this rank the analytical function to understand more in detail. So here we are in our SQL developer. Let's see the data in our employee table. So we have a salary column in our employee table. So let's calculate the rank of each employee in a table based on this salary column. So here we have the query. We are selecting the employee ID, employee name, the salary, and post that we are applying our analytical function rank on salary column. So the syntax is rank, then we need to use the keyword over, and inside the braces we can define our column on which we need to find the rank, which is salary, either in ascending order or in descending order. So this time we are calculating it based on descending order. So the highest salary will get first rank, then the next second highest will get the next rank, and so on. So let's trigger this, and here we have the output. The top salary, which is 5 lakh, is getting the rank as 1. If you notice here, we have two employees with the salary 5 lakh rupees, and both of them has got the rank as 1. The next employee, who is having the salary as 4 lakh, has got the rank as 3, and so on. So this is how we calculate the rank using this rank analytical function. The next analytical function is dense rank. This function also calculates the rank of a row in a group of rows and returns a rank as a number. Here also the rows with the equal values receives the same rank, but it does not skip the rank value in the event of ties. This function also uses the over keyword, which is nothing but an analytical clause to indicate that the analytical functions are implemented on a query once all the group by having clauses are completed. If we look at the table where we have the salary and the corresponding dense ranks, in the event of the tie for the salary 29,000, it assigns the same rank to both the salaries, but when it calculates the next rank in the table, it does not skip the number as it was skipping in the case of rank. Let's look at the syntax of dense rank function. So it is dense rank followed by the over keyword, and then inside the braces we can define the column name on which we need to partition our data, and then the column on which we need to find the dense rank in our table, either in ascending order or in descending order. So let's look at some of the examples of dense rank analytical function and try to understand more about this. So this time also, let's calculate the rank of the employees based on the salary column. But instead of using the rank analytical function, let's use the dense rank analytical function and see what are the ranks it assigns to each row in the table. So here we have the query. We have selected employee ID, employee name, and salary column from our employee table. And then we have used the dense rank analytical function followed by the over keyword. And inside the braces, we have defined the column on which we need to calculate the dense rank of the employees in descending order. So let's go ahead and run this query. So here we have the result. If you notice, the employee King and Scott are having the same salary, 5 lakh rupees, and they both have got the rank as 1. Whereas the next employee, Ford, is having the 4 lakh salary, but this time using the dense rank analytical function, he has got the rank as 2, and hence it is not skipping, it assigns the ranks in continue order. We can also use the partition by keyword to partition the data based on the department number and assigns the ranks. So here we have the output. If you notice here, it this time it is assigning the rank inside each department. So it first calculates the rank for department number 10, and under this department we have 3 employees with different salaries, and hence it has assigned the rank as 1 to 3. Then it moves to next department, which is department number 20, and it assigns the rank to each employee under that department, and then it moves to department number 30 and it repeats the same thing and assigns the rank for each employee in department 30. If you notice here, under each department, wherever we have the same salary, it is assigning the same rank. So that is how we can partition the data also and calculate the ranks inside each group. The last analytical function is row number. It assigns a unique number to each row either in a group or in each row returned by the query. For a consistent result, the query must be sorted on a specific column like we did in case of rank and dense rank analytical functions. Like you can see here in the given table, we are calculating the row num for the salaries. So even though the salary is tied in the third and fourth row, it does not assign the same number to it. It consistently assigns the number in an incremental fashion. So let's look at the syntax of row num analytical function, which is exactly similar to the rank and dense rank analytical functions. So this time, instead of using those rank or dense rank functions, we are using row number function followed by the over keyword, which is nothing but an analytical clause, and inside the braces we can define our partition by column and the column on which we need to calculate the row number for the table, either in ascending order or in a descending order. Let's switch to SQL Developer. and see some examples of using this row number analytical function. So let's calculate the row number of each employee in the table based on the salary column in descending order. So here we have the query. We are selecting the three columns from our employee table, and they are employee ID, employee name, and salary. After this, we are applying a row number analytical function followed by the over keyword, and then inside the braces we are defining the column on which we need to calculate the row number for our table. So instead of this alias, I can change it to row num of the salary. So here we have the output. So if you notice, each employee inside the table has got a unique number starting from 1 all the way to 14. We can also use the partition by keyword and calculate the row number to each group. So let's partition this table based on department number and calculate the row number to each employee inside the department. This time, if you notice here, we have three employees under department number 10, and all three are getting the ranks, sorry, row numbers as 1, 2, and 3. Then second, inside department number 20, we have 5 employees, and they have also got the row numbers as 1, 2, 3, 4, 5. And at the end, the department number 30 is having 6 employees, and they have also got the same row numbers. So this is how we use the analytical functions rank, dance rank, and row numbers. They are very useful in real-time examples, and we will see their use cases when we will start with our scenario-based interview question series. So that's it for this lecture. I hope you liked it. Thanks for watching. We'll see you in the next one. Thank you.